So this is my video on solving a rational inequality. So we did linear and quadratic, and now we are going to do rational, right? And first of all, remember, so rational means there is a denominator, right, with x in it, right? So we want to make sure that you bring everything onto the left hand side, just like the quadratic, okay, situation. We are leaving only 0 on the right hand side. So let's try to do that. So what happens is you subtract 0 from you subtract 3 from the right hand side. So the 3 comes over here and then you become 0. Okay, the right hand side becomes 0. So you now need to make sure that you bring this under common denominator, right? Okay, so if you bring this under common denominator, the LCD is x minus 5. So it's 2x minus 7, and you multiply this by the LCD, which is x minus 5, and you want it to be less than 0. So if you FOIL this now, you get 2x minus 7 minus 3x plus 15 divided by x minus 5, and you want it to be less than 0. So 2x minus 3x is minus x, 15 minus 7 is plus 8 over x minus 5, and you want it to be less than 0. Okay, so now you do have some key points here again, just like the roots, but now you must look at the roots of the kind of, they're not really roots, but roots of the top and the bottom both. Okay, so we have key points are, so if you look at the root of the top, it's 8, right? X equals 8, and the root at the bottom is 5. So then again, once again, you look at the intervals like last time. Okay, so you have a 5 here and you have 8 here, so you get test points, test here, test here. So test point here would be x equals 0, and x equals maybe 6, and maybe x equals 10 here. So let's just plug in the numbers into this one, right, and see whether you get the correct sign. So you put 0 here, you get negative 0 plus 8 over 0 minus 5, which is I'm sorry. So what happened here was we put so once again the key points were 8 and 5, right? Okay, so we created the boundaries 5 and 8, and we looked at the test values of less than 5 between 5 and 8, and test values greater than 8. So test value less than 5 0, test values between 5 and 8 are 6, and test values greater than 8 are 10. So once again, how did you get the key points? We looked at the roots on top, which are 8, and roots on the bottom, which are 5. So let's put 0, and then you put 0, you get negative 0 plus 8 over 0 minus 5, which will be negative 8 over 5, which is negative. So that's the sign that we want. So that's correct. That's in the correct range. But if you put 6 here, what will you, let's see what happens. So you put 6 here, you get negative 6 plus 8 over 6 minus 5, which will be 2 over 1, which is positive, right? Which we do not want because we want the negative. So that's out. So this region is out. So now let's put 10 and see, right? So negative 10 plus 8 over 10 minus 5. So negative 10 plus 8 is negative 2. 10 minus 5 is 5. And it's negative, which is what we want. So that's in the correct region. So what's the answer then? We can take both these regions. X is less than 5 and X is greater than 8. Okay. So the answer would be, you can write the answer here. So X is X is greater than 8. So if you want to put the interval notation, because it is less than 5, everything less than 5. So from negative infinity to 5, union everything after 8. So from 8 all the way to infinity. Make sure that you put the open parentheses here. So if you want to put it on the number line, it's 5 and 8. So you have negative infinity to 5 all the way up to 5, and then all the way after 8. You want to make sure that you put the correct parentheses. Okay, and that's how you solve irrational inequality. So remember, you want to make sure that you bring everything onto the to one side, leaving only the 0 on there. So you need to take the 3, subtract it from both sides, and then you factor it, and then you usually get denominator and numerator. Make sure that you get the roots, not the real roots, but really they're not really, well, they are kind of, but as far as inequality is concerned, so those are the key points. So here you get 2 key points, 8 and 5, and then you just break up the real line into those regions, and you take test values and test, and you get the correct region. That's what you do. Okay, that's how you solve a rational inequality.